Hello, these are the notes on integrating the natural log function, and they're section 5.2 in our book. And so here's the idea behind it is you're looking for something like this, where you have an integral, okay, because we're integrating, and I'll write an indefinite integral. And down here you have u. And now what I'm going to show you about u is to the first power. So usually what we do is we would take that and we'd write u to the negative 1 power du. And I would take that negative 1 and I'd add 1 to it, and in this case I would get 0. And then I'd multiply by the reciprocal, which in this case would be 1 over 0. Well, that causes a lot of problems. So we can't do it this way. So what we do is we take a look at some type of expression in the denominator that's to the first power. And in the numerator, if you recall, when you take the derivative, you're going to have, now this is an exponent of 1. Right here, this is going to be a derivative, so I'm going to make it more slanty. The differentiation of u is up here. So if you recall from chapter 5.1, you always, when you took the derivative, you always had something in the denominator and its derivative on top, and so that's what you look for. So if I had something like this, let me give you this as an example. Right here, I'm going to have, let's say I have x squared plus 2, and in the numerator I have 2x. Over here dx. So what I do is I put parentheses around this quantity. I raise it to the first power. And because I have a quantity to the first power, I'm thinking, hey, what I got here is a natural log. And so I'm going to get natural log as an answer. And my next step then is to take a look at this quantity in here and take a look at its derivative and see if that's what's existing up here in the numerator. Well, the derivative of x squared plus 2 is 2x, so it is. So some students will take a look at this and say, well, that's obviously got to be the natural log of x squared plus 2, the absolute value, plus c. And if you take the derivative of this, you'd end up getting this thing right here. I mean, that's where some students will be. Some other students will use substitution. And so they'll go to this quantity here, this x squared plus 2, and they'll assign that to be u. And then they'll take the derivative of du dx, and they'll get 2x, which is what they see right here. And so that means du is equal to 2x dx. And there's my 2x dx right here. And that's going to be replaced with du. Now you have to remember that's 1 du. So when I rewrite it, up here I'm going to have a 1. Down here I'm going to have a u. And over here I have du. And the antiderivative of that is going to be the natural log of the absolute value of u plus c. And then I'm going to take this value right here and put it in to u, and I'm going to have the natural log of x squared plus 2 plus c. All right, so that's kind of where we're heading, and I just did an example, and I'm going to start with example 1. Example 1 has something like this. I'm taking the derivative of x plus 1 divided by x squared plus 2x dx. So my first step is to gather around with parentheses, and I write its exponent, which is 1. And then I take a look at its derivative. Its derivative is 2x plus 2, which isn't 2x plus 2. X plus 1 is simply that times 2. So it looks like there's a relationship. So I'm going to let u be x squared plus 2x. It means du dx, excuse me, is equal to 2x plus 2. Well, that means du dx is equal to 2, and I'll factor out the x plus 1. And then I have du is equal to 2 times x plus 1 times dx. Well, this is the part that I want. This is the part that's going to substitute in for this right here. Okay, and so what I'm going to do, rewrite this then, is 1/2 du is equal to x plus 1 dx. So this is going to replace this. So now what I have is 1 over, well, what was this? That's u, isn't it? So it's u. And right here I have 1/2, which is my constant. It comes from this. Here's du. Comes from this. And I'm going to take the derivative of that, so it's going to be 1/2 the natural log of the absolute value of u plus c. Well, what's u? U is x squared plus 2x. So I have 1/2 the natural log of x squared plus 2x plus c. Now let's say that's equal to some y, and I, just as a check, I'm going to take the derivative. I should end up with this expression right here. So dy dx would equal to 1/2 times x squared plus 2x. Up here I'd have 2x plus 2. And then that c would be 0. And that's equal to 1/2 times 2 times x plus 1 over x squared plus 2x. And I can simplify here. And that's where I get the x plus 1 over x squared plus 2x. So I just did that to demonstrate that when you take the derivative, you're back to where you started. All right? All right, let's look at the next one. Number 2. I'm integrating 1 over 3x plus 2 to the first power dx. So I'm looking at this. The derivative of it is 3. That's a constant. It's going to end up, I can end up getting a 3 in here, or a 1/3. I'm going to show you how I do that. I'm going to let u equal 3x plus 1. So du dx is equal to 3. So du equals 3 dx. I don't have a 3 dx, so I'm going to need a 1/3 du to replace dx. So I'm going to end up with a 1/3 here. I'm going to end up with 1 over u du. So there's 1/3 du is this dx. So it's going to be 1/3 the natural log of the absolute value of u plus c. So that's going to be natural log. And now I'm going to do a couple of things here. This 1/3 is an exponent. It's a cube root. What is it a cube root of? 3x plus 1. And out here I have a plus c. All right. Number 3. Let's take a look at that. I'm going to clear this. And it's going to be number 3. It's going to be trig. And I'm going to have secant squared x dx. Oops. Let me just delete that quickly. Secant squared x over the tangent of x, dx. That's what I want. Now, the derivative of tangent is secant squared. So if I put parentheses around there, again, this is the first part. I'm going to let u equal tangent of x. Du dx is equal to secant squared x. And so du is equal to secant squared x dx. That's this part right here. So now again I have 1 over u, and notice it always looks like this most of the time. So I have the natural log of the absolute value of the tangent of x, because that's what u is, plus c. So I went from here to the natural log of the absolute value of u plus c, and then I did my substitution at that point. All right? Number 4. I have 1 over 4x minus 1 dx. I know I'm going to have a constant here as my derivative, and it's probably going to have 1/4 in it. You should start seeing some type of relationship that the reciprocal of this ends up being part of my antiderivative. So I'm going to let u equal 4x minus 1 du dx is equal to 4 du is equal to 4 dx. 1/4 du is equal to dx. So I have 1/4 1 over u du. So that means I have the natural log 1/4 the natural log of the absolute value of u plus c, and I'm going to write my final answer as the natural log of the 4th root of 4x minus 1 plus c. Number 5. Number 5 and 6 are true proofs. So I'm going to find the integral of the tangent of x dx. So I'm going to rewrite that first of all as the sine of x over the cosine of x dx. The derivative of cosine is negative sine, so it looks like I'm going to be able to use substitution here. So I'm going to let u equal the cosine of x, and that means du dx is equal to the negative sine of x dx. So that means du is equal to, oops, I didn't want this. It's just equal to the negative sine of x. Now du is equal to the negative sine of x dx. I want that now. I don't have a negative sine of dx. I have a positive, so I'm going to rewrite that a negative du is equal to sine of x dx. And so to replace the sine of x dx, I'll need a negative du, so I'm going to bring that negative 1 out in front. And I'm going to have 1 over u, remember that cosine is replaced with u, du, and so I'm going to have a negative natural log of the absolute value of u plus c. So that gives me a negative natural log, what's u? The cosine of x plus c. Alright? Number 6 is a proof, and this was a proof. This is proof of the integral of the tangent of x. And I'm going to take a look at the proof for the cotangent of x. And that's number 6. And number 6 looks like this. I'm going to integrate the cotangent of x dx. I'm going to start out the same way. That is the same as the cosine of x over the sine of x dx. I'm going to put parentheses around that. That's the first power. The derivative of sine is cosine. So I'm going to let u equal the sine of x. That means du dx is equal to the cosine of x. Du is equal to the cosine of x dx. So when I substitute, I'm going to get 1 over u du. And so I have the natural log of the absolute value of u plus c. What's u? That's equal to sine of x. So the antiderivative of the cotangent x is a natural log of the sine of x plus c. Alright, I'm going to stop here, and I will have a second part to the notes.